equilibrium, and then what I was doing the basic equation we are trying to solve, FIL TP x bar equals to FIB TP y bar. Right? Temperature pressure is taken account, so you can actually have this only one equation for all the components. Okay, so this is the basic equation, and we have done for the low pressure. At low pressure, we have done the calculation. At low pressure, this FIL equals to, what will be the FIL for low pressure? We have done last class. FIL in low pressure will be what? What is that? FIL in low pressure? FIL equals to FIB, low pressure. We don't even read the questions, read the notes. FIL and FIB can be treated separately. You are saying FIL equals to FIB, it is written there. FIL equals to FIB. You don't have to tell anything extra. How to approach a low pressure? What's the next step? You don't even go to the notes. You just come here and just arbitrarily. What's the next step? FIL. What is the special to the rule for FIL? Pardon? Lewis standard rule. Yes. So they don't even know that. Lewis standard rule. Xi, Fi star, and FIB at low pressure is Yi, total pressure. And then we have proved last class that Fi star, that is actually pure component fugacity, and the pure component fugacity and the total pressure, the saturation pressure has been related with, right? That we have seen that F by P sat is some correction factor is that low pressure, that T part 0 equals to 1, and that is equals to Xi, Pi sat equals to Yip equals to partial pressure, and that was the Raoult's law. So I tell so many times and you forget so many times. Okay? Because you can forget it, no problem. So those type of things were discussed, and we have discussed how to draw the Txy and Txy diagram, and we also last class we discussed about how to calculate the bubble point and how to do the bubble pressure point and dew point calculation. For the bubble point, the calculation is Pix Xi PiTBP, bubble point, and we can have P equals to X summation Xi Pi PB. For dew point calculation or basic equation, so here bubble point basic equation is P, and dew point basic equation is dew point calculation basic equation is not 1 by summation Xi equals to 1, I equals to 1 to C, summation Xi equals to 1, and dew point what actually is given. So you have the Raoult's law, which is Xi Pi sat equals to Yi into capital P, right? So what will you get? You will get summation I equals to 1 to C Yip by Pi sat equals to 1. Because why dew point? Because dew point what is given? Y is given, right? Dew point Y is given. Dew point Y is given. Bubble point X is given. You please see what is given. That's what is data. I have given the chart also. I have given the chart. Dew point Y is given. So you have to replace X by Y. And if you replace this is the type of equation you have to solve. So these are the catch, these are the things to be there. So when you have the bubble pressure point and dew point calculation, these things are pretty important. So bubble and dew point calculations. Second problem set 2. Fourth assignment, second problem. Calculate the temperature and composition. First is the bubble point calculation. Second is the dew point calculation. So we'll start. We'll see this thing how it can be applied. Remember that bubble point Xi is given. Sometimes temperature may be given. Sometimes pressure. If temperature is given, easy. So if temperature is given, direct solution. if temperature, if pressure given, temperature unknown, iterative solution. So both the cases, we have the two situations. The temperature is given, we have direct solution. The temperature is not given, in that case you don't know Psak sat, because the temperature is given. If the temperature is given, because your Psak is given by Antoine equation, log 10 Psak, which is A minus, am I correct? Antoine equation, log 10 Psak is A minus B by T plus C. Log 10 Psak equals to A minus B by T plus C. So if you look at temperature is given, this Psak is known. The temperature is not given. We have to calculate, we have to do some interesting stuff to see how it can be done. So let's look at the second problem, first part. Calculate the temperature. Yes, so that means the problem is it is a second category problem. Iterative solution type of problem. Second category problem. Calculate the temperature and composition of a vapor in equilibrium with a liquid that is 40 mole % benzene and 60 mole % chlorine at 1 atmosphere. Is the calculated temperature bubble point or dew point temperature? So since liquid fraction is given, you close your eyes and say bubble point. There's a bubble point calculation. So first part is bubble point calculation. 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 Okay. So is that so for the bubble point calculation, what is my basic equation? This is my basic equation, right? Summation xi ti bubble point equals to capital P, right? Just combine the Raoult's law. That's the way we have done actually. Okay. Correct. Okay. Pi sat, I should say. You can say sat. Pi sat. So what will be your equation then? Because this is combined with Raoult's law, right? It's actually written from Raoult's law. First is 0.4, right? 0.4 P first component P1 sat at TBP plus 0.6 P2 sat TBP equals to 760 millimeter of mercury. 1 atmosphere, right? 760 millimeter of mercury. And how to calculate Psat? Psat A, B, C are given for the benzene and chlorine. Is that given in a table form? Yes or no? Yeah. So A, B, C are given in a table form. So what you are getting here? 0.4 exponential. See, so complicated it is. It is not as straightforward. 0.4 exponential A of 1 minus B of 1 by T of 1, sorry, TBP plus C1, am I correct? 10 to the power. That's the way I would like that computer, right? Similarly, 0.6 10 to the power A2 minus B2 by TBP plus C2 minus 760 equals to a function of TBP. Nonlinear equation. We have to do by iteration. What method we will take? We will do Newton-Raphson method. How to do Newton-Raphson method for this problem? We have to do by Newton-Raphson method. This is correct. So, how to do by Newton-Raphson method? How to do by Newton-Raphson method? introduction that says that from there TBP new equals to TBP old minus F of TBP old by F prime TBP old. Am I correct? Generally bubble point goes near to 100 or something. So we give initial guess roughly 80 degrees centigrade. Don't give 40 or 50 because you know the bubbling occurs at high temperature. That's our intuition how to give initial guess. Okay? So TDP old is 80 degrees centigrade minus supply me FTP old, how much it is coming? You put the values, calculator, you have the memory. This thing you calculate, TBP will be only changing. And this equation in terms of degree centigrade, not degree Kelvin. So very straightforward. So FTBP old, how much it is coming? FTBP old. FTBP old. FTBP old, how much is this coming? So you have to put 0.4 to 10 to the power A1 by G1 by TBP plus C1. Okay. A1, B1, C1 are known. Now TBP old is known, which is 80 degrees centigrade. TBP is known, which is 80 degrees centigrade. TBP old. Use the calculator memory function. Use the calculator memory function. How much it is coming? FTBP or how much it is coming? Minus 282. Is it correct? 282.8, huh? How much? 148. Is that correct? Yes or no? Okay. Now you have to calculate F prime. F prime is not that easy. I am getting scared to see that. What I will tell to you. I am getting scared to calculate. But there is a way to calculate F prime, which is very straightforward. F prime x is defined as fx delta x minus fx by delta x limit delta x tending to 0 from 10 plus to calculus. So you have something called numerical Jacobian method, a numerical derivative method. When the derivative calculation is very difficult, you cannot calculate derivative. Sometimes, now you can see the function. Sometimes function is like a black box. Only you give the input, you get output. You don't know what's the function. Like a black box. Okay? Just like a, if you change the pressure, you get the flow rate. But you don't know what's the function. So like that. In that case, you have to do by numerical derivative because you don't know the function. Here also the function is very complicated. I don't want to talk about derivative. What we will do? I will have the same kind of concept, f prime x, which is fx plus epsilon minus fx by epsilon, where epsilon is 10 to the power minus 3 or minus 4 is better. Now you can store it, this value is stored. What is that value? Minus 282.148. How much is this one? So your TBP will be, value will be 80.0001. So this will be calculated as, so TBP plus epsilon will be 80.1231. Am I correct? Epsilon value is what? 0001. That should be calculated here. So you put the 80.0001, calculate the fx plus epsilon. Fx is already there, which is minus 22.148. Epsilon is to the minus 3. So you will get the derivative. Easy way, no? Okay, do it. Get the answer for me. At least for one iteration. This kind of problem is coming in the exam. Next semester.
Epsilon we take on our
Yeah, you can actually, it's better because if you take higher value, convergence may be tougher. Sometimes you don't get good convergence. If you take small value, it's better. Because what is the role of F prime? F prime doesn't have any role for introduction method. Even sometimes people have wrong F prime calculation, they get correct answer. You know why? I'll tell you in introduction how it works. This is my solution, right? This is my initial guess. If your derivative is correct, we will approach. Sometimes my friend is calculating wrong derivative. Instead of going like that, he is going like this. We will take more steps. But if you do wrong calculation, sometimes derivative will be going this way, you won't get convergence. So derivative actually gives the direction of convergence in introduction method. Derivative gives direction of the convergence. So in that case, in introduction method, if you look at, I don't know your math class whether numerical techniques have been started or not. I think soon it will be started. And it can be proved that in the next semester I will be talking about all those things, introduction method, how the convergence speed, and it will show that the convergence is quadratic convergence, where the second method or successive substitution method where the convergence is much slower. So those kind of things are discussed. But right now you can see that this derivative calculation, you can put minus 4, minus 3, it does not matter. Only thing is it is slower by the speed of the convergence. If you put minus 4, you may get in 3 iterations. If you put minus 3, you may get in 4 iterations. If you put minus 2, you may get in 5 or 6 iterations. Okay? That is your choice. Because if you do poor convergence, poor derivative, that maybe derivative is like that, and it is slowly going to that. The tangent direction is the fastest direction. Because it gives the exact derivative at the exact direction, which is much faster. Okay, so how much it is coming? Pardon? How much? 15. 1.5 she is getting. She is getting 1.5. Any more calls? I got one answer, 15. Any more calls? I got one answer, 15. How much you get? You put epsilon 10 to the 4? Minus 4 you have put, correct. Let's see. I don't have the result with me. So can I give you a task? Maybe next week. Solve this problem by iteration technique and give me the problem. Solve problem. Okay. This time I am asking you, I am not asking Rahul. Rahul has done enough. I am asking you. We can do it, right? So write the problem and do this iteration. Complete this problem like this. Double point and do point. Good exercise for you. You will be getting advantage because in the exam you can do very fast. Okay, so next week sometime, maybe Monday or Friday. Friday is better, right? Okay. F prime. How much he is getting? 50 is correct? Okay, very good. Thanks. So you have done. How much is now coming? Yes, this TVP new?
98.809.
Pardon?
98.8.
98.80.
8099.
8099. Next, I want you to do one more iteration. The answer is not 98, it is less than 98. So I want to see how it is going. Huh?
answer is 95 for the graph. We can see
Which graph?
the TXY graph.
Okay, TXY graph, yes, but I want to see the TXY graph. But next iteration, can you do it quickly? Now you know how to do it, right? You have learned how to do numerical Jacobian, right? Do it fast. Do it fast. Next will be TBP new. Next iteration. I want you to feel the solution. Otherwise, I don't feel like to go to the next topic. Because you should feel for that, no? TBP new. It is coming 98 point, how much? 8, right?
8.
Yes, 98.8 roughly. F of 98.8 and F prime of 98.8. Quickly tell me how much you got. F 98.8. So Rahul knows the answer from the TXY diagram. I don't know the answer. So I have to do the solution. You should go in 2 to 3 iterations. Engg 98.8, function 98.8. How much is coming?
95.289.
95.289. Any calls? 95.289. I don't have the answer with me. I don't have answer with me, so you have to. I am relying on you. I am relying on you. Yes, how much you are getting? F prime. Anybody got F 98.8? Function value? You are not getting? 84 you are getting.
Function value is 84.64.
Function derivative.
Derivative,
You say
84.6439.
84.64. Anybody got this one? These values? Function derivative both? Function value is 84. But she is getting derivative 84.
No, function value is 84.
That's what when I write to just tell something else, how can I am getting the confused in the entire class. Tell me correctly what is 84, what is 95? What is function value?
F of x is 84.6415.
84.615. Then derivative
24.04.
34.
24.
24.04. Is that acceptable to all the people who got it? Function and derivative? 24.5 you got. And what's about? These are correct. So next, how much you are getting? 95.2. So how's the convergence check? Convergence check you have to see this at the convergence. When you get the correct convergence, function should be 0, right? When it is converged, has to be satisfied. Function has to be 0. So till that you have to do the calculation. I think after the second iteration you can convert. So this method works fine. So with this method, you have to have intuitive guess. Bubble point is 75 to 80 is a good guess. Dew point is 30 to 40 is a good guess. Dew point. So next problem you can do. You will go through. So the answer is. So we now go to the. We have to find out y, right? yi equals to p xi pi sat by total p. Okay. So how much you are getting? Total p is 760. And particular temperature 95.1 you have to calculate. And you will get, I'll give the answer, you can actually go back home and do it. 0.62 y1 and y2 is 0.378. Of course, this add up to be 1. Next problem, second part. Dew point calculation. What's the equation for dew point? Dew point equation will be summation xi equals to 1. That means summation yip by pi sat equals to 1. Summation yip, summation I equals to 1 to c, yip by pi sat equals to 1. Correct? Okay, so do it for this problem. So y is given. Dew point calculation y is given. y1p by p1 sat, function of dew point dt plus y2p p2 sat, function of dew point. I think temperature is again unknown, which is equals to 1. Am I correct? Yes. So this calculation, I think you have to go back home and do it, because this is not I can do it in the class because it takes long time, because this thing is actually there, the thing. So we have P equals to 1 by Y1 by P1 sat plus, am I correct? These are final equation. P is 760 meter of mercury, correct? So how to do that? In the iteration method, you have to give initial guess of the dew point. You have to give the initial guess of the dew point. And what's the initial guess for the dew point? 30 to 40 degree. You can give roughly 40 degree. 30 degree, 40 degree, whatever you can give. Doesn't matter. If you give 30 degree also, it will give. First iteration is very quick. Then slow it will convert. You know that. First part it will directly dip to the solution nearby the solution. So give the initial guess of 30 to 40 degree. Do the iteration like that in numerical Jacobian method to get the answer. The answer is 52.4 degrees centigrade. TDP is 52.4 degrees centigrade. Third problem is nitrogen is insoluble, right? Something is given as a third problem. Third problem, a gas mixture containing 15 mole percent benzene, 10 mole percent chlorine, and 75 mole percent of nitrogen is compressed isothermally at 80 degree centigrade until condensation occurs. This problem is a very easy problem because temperature is given, no iteration is required. At what pressure will condensation begin? What will be the composition of the initial condensate? So it is a what problem? Bubble point or dew point? Dew point, because gas mixture is given. Dew point is given and the dew pressure calculation. It's not the temperature. The temperature is given, which is 80 degree centigrade, right? So can you solve it? And remember that nitrogen is insoluble. Nitrogen is present only in the gas phase, not in the liquid phase. So what will be the answer? The temperature is given, so there is no iteration required. You can directly put in the Engg equation and get the solution. You can directly put in the Engg equation and get the solution. So tell me the solution. So it is a dew pressure calculation. So your equation is again summation of xi equals to 1, I equals to 1 to c. So it is, what should be your equation? Mole fraction. What are the things should be there in the liquid phase? What are the components should be there in the liquid phase? Benzene and chlorine. There is no nitrogen. So it is Y1P by P1 sat 80 degree centigrade plus Y2P by P2 sat 80 degree centigrade equals to 1. Okay, calculate the 80 degree centigrade P1 sat and P2 sat from the electronics equation and get to the pressure. Pressure is unknown. So pressure is 1 by Y1 P1 sat 80 degree centigrade plus Y2 P2 sat 80 degree centigrade equals to P1 sat. How much you got? Anything quick? 757.3 and P2 291.2. That's it. So what's the P value? Y1, Y2 are given. Y1 is 0.15 and Y2 is 0.1, right? Y1 is 0.15, Y2 is 0.1, right? Yes. So if you put that, what you are getting P value? P value, how much you are getting? Value of P, how much you are getting? How much you got value of P? Yes, madam. 1847 Newton of mercury. And then that's it. You can calculate x1 by x1 and x2, right? X1 is, now you got the P. Now x1 is Y1P by P1 sat. Y1 is known, P is known, P1 set is known, that's it. So P is known, so you can get the XA and XB, X1, X2 is 0.366 and 0.634 if you calculate. So that's the way I think you have done fairly. Two types you have done. If the pressure is given, how to calculate temperature is a tedious process, iteration process. The temperature is given, how to calculate the pressure. So you have got now good grasp of knowledge how to do vapor liquid equilibrium for binary system for the low pressure. I hope that any problem can be given to you can solve, because the way I have taught in the class, low pressure, Raoult's law, there are 4 kinds of problems: bubble point, bubble pressure calculation, bubble temperature calculation, dew point temperature calculation, dew pressure calculation. With that you can actually solve it. Now question is non-ideality. If non-ideality comes, how the system will behave. For example, so now we are exploring into non-ideal situation where the low pressure situation may not be there, Raoult's law may not be valid exactly, how to handle the situation. So non-ideality. Non-ideality. What we have seen earlier, Fi L P P X bar equals to Fi V P P Y bar, right? And we have found Raoult's law, Lewis standard rule, and this is YI. Okay, and this thing is a fugacity for the pure component, and we have the rule. What is the rule? F by P exponential mu minus mu Ig. And if you talk about this, it is 1 by RT exponential of this. What I am saying that if the liquid phase pressure is not low, then some accountability will be there for this term. Okay? So what actually happens? This entire thing will be written, can be written as some multiplication factor xi pi sat equals to yip. Some multiplication factor will be there because of this. This is called as activity coefficient. So now you can see what's the fundamental or the rationale for the activity coefficient. This is called as activity coefficient. This is called as activity coefficient. Now for the, so that means what? The liquid phase, and this activity coefficient model is valid for the moderate pressure. The high pressure does not be valid again. So the gas phase will behave ideal, but the liquid phase will not behave ideal. In that case, you can have modified principle, which may be called as modified Raoult's law. I don't know what it should be called, but this is the equation you can get. And the main issue is how to determine the activity coefficient. So, point is how to determine activity coefficient. For determination of activity coefficient, we need to have models. We might have seen the models. What are the models we might have seen? Margulas equation we have seen earlier. Then what are the models we have seen? Pardon? Unifact we have seen. Excellent. Uniquark will come fast. Deadly crystal method. Have you heard? Okay, we'll talk about deadly crystal, uniquark, unifact. Do you know how to derive? Okay, that's what that is thermodynamics. So you'll be deriving all these formulas. Okay, so before going to that, we will talk something on excess free energy to get the more concepts on gamma R, activity coefficient. Excess free energy. Excess free energy. Non-ideal, so the excess property. So capital GE, excess free energy, which can be defined as G minus GIS. IS is ideal solution. Okay. So any excess property FE we can define as M minus MIS. M is the extensive property. M is the extensive property. M is the extensive property. Okay, so you can write this as summation I equals to 1 to C. What you can write in terms of intensive property or specific properties? Ni mixture. Solution is a mixture. Ni. Any more hands? Ni. We have done the solution, the mixture. Yes. Gi bar minus Gi bar is. Gi bar, don't say Gi bar, there will be 0, right? Gi bar is ideal solution, which is also written as, yes, mu I equals to 1 to C Ni mu I minus mu I is. Equation number 8. You cannot do much with this IS because if you look at the fugacity definition, it depends on IgM, and we know that IgM is not equal to IS. There is some difference. Okay, so fugacity definition, if you look at Fi by Pxi is exponential mu minus mu IgM by RT. Am I correct? Pardon? This RT should be inside or outside? Inside. Okay. So mu minus mu IgM by RT. So, and this is IS. So you have to do something, right, to get some good expression. How to approach? You cannot get the excess property in terms of fugacity because you have IgM and here you have IS. So let's look at how to approach to some good expression, and then finally you can get activity coefficient, some kind of estimate. So Ge equals to summation I equals to 1 to C Ni mu I minus mu Is. So you can write mu I IgM, then plus mu I IgM minus mu I IgM minus mu Is you can write, but you cannot get anything out of that. I know Ig if you have relationship, then mu I Ig minus mu I Is. G equals to summation I equals to 1 to C Ni. What should we write? Mu I minus mu IgM. Sorry, it is RT. So ln Fi by Pxi. Am I correct? RT ln Fi by Pxi. Mu I IgM minus mu Ig. We have the relationship. What is the relationship? RT ln Xi. Mu Ig minus mu Is. I have done also this part. So mu Ig we have that relationship, right? Or yeah, I think you can directly go for that. Mu Is. What is that? Mu Ig minus mu Is. Here you can say that mu I Ig mu Is are not same. Of course, mu Is is the ideal solution. What is mu Is? Mu I star, yes. Mu I star Tp plus or minus. Get got cancelled, right? Okay. What did you get finally? Summation I equals to 1 to C Ni RT ln Fi by Pxi minus mu I Ig minus mu I star Tp. Mu I star depends on the pure substance, right? Can you have any relationship here? Let's see, who can tell me? Mu I star is a pure substance. Mu I is ideal gas.
So from FIP to
I have done like that Fi star by P, which is exponential mu I star minus mu I Ig by RT, pure substance. Pure substance, what is that? F by P equals to exponential mu minus mu Ig by RT. Right? This talks about pure substance, not Ig. This Ig. Okay, so I have done the class earlier. This star means the pure substance. Okay? So this will be replaced by RT
minus RT.
RT what? Minus RT, that's all, huh?
No, minus RT ln.
ln?
Fi star by P.
Am I correct? Yes. What did you get finally? Summation I equals to 1 to C Ni. RT you can take outside. Ni ln Fi by we got RT Ni ln Fi Xi Fi star, and this is termed as activity coefficient. This is termed as activity coefficient. Fi Xi Fi star is termed as activity coefficient. Okay, that is termed as activity coefficient. Correct? So you got G equals to RT, summation I equals to 1 to C, Ni ln gamma. You got Ge equals to RT, summation I equals to 1 to C, Ni ln gamma. This is called as activity coefficient. Gamma is called as activity coefficient. Remember that I gave a problem in the class on the fugacity, and I asked you to check whether fugacity of I component satisfies that Gibbs-Duhem relationship. You check it. I gave that problem, right, in the class to solve. Remember that I gave a problem. The fugacity of ith component is Fi. In that case, you have to see that how it satisfies the Gibbs-Duhem relationship. So similarly for the activity coefficient, it is possible to establish something called Gibbs-Duhem relationship, which will be helpful to have the proper model of activity coefficient. So Gibbs-Duhem relationship for models of gamma I. We got G equals to RT summation Ni ln gamma I. We also know that G is summation Ni Gi bar. That we know now. It is very common. I equals to 1 to C. I equals to 1 to C. Ni dou G by dou G by dou Ni Tp Nj not equals to 1. So we have dou G by dou Ni Tp Nj J not equals to 1. What will happen? You can write this as what you can write from here. If you take derivative, what you will get? RT is common, you can take it outside. Dou to Ni, if Ni kept constant, we have ln gamma I, right? So what did you get? Summation I equals to 1 to C. You can actually have K equals to 1 to C, better, but don't get any confusion. Otherwise you get confusion, get wrong results. Instead of I, you can write K, no problem. So you can have another. Generally, when you have index, you generally try to put more generalized. It is better, so you won't miss out. So what are the terms? K equals 1 to C. K equals to 1 to C in K dou ln gamma K by dou Ni plus K equals to 1 to C ln gamma K dou Nk dou Ni. Am I correct? Yes. I am putting more generalized. Then what you are getting? This is conical delta, right? Delta Ik. If there is a conical delta, the summation term will go. We will have ln gamma I, right? So you have RT ln gamma I, correct? Then RT, then plus RT. K equals to 1 to C Nk dou ln gamma K dou Ni.